works for a presentation. The first one is that with the in our screen. It will be presented by Dr. Saroj Koul, and we also find in the session Dr. Rakesh Verma. Dr. Saroj Koul, please start your presentation.
Yeah, thank you very much. And my name is Saroj Koul. I will be presenting a short paper, a crisp paper. Professor Verma and Ajaygopal, who are also co-authors for the paper, they will also be speaking for the responses. If there are too many, I will take a couple of what is called as only 8 to 10 minutes to make a presentation. So as we look at the topic, Industry 4.0 technologies, this is one of the terms. The other term is reverse logistics. And the third term, which is of particular interest to us, is an integration of the Bayesian best-worst method and COBRA method. So we will look at the decision making through an integrated method of two things. And we will work on the Industry 4.0 technologies, and we will look at what happens in the reverse logistics area. So as we are clear, as we know, in a supply chain, we have a logistic part. It can be inbound, it can be outbound. But as soon as we receive material at the client end or at the customer's end, I may have to go to the second slide and come back here. So at the client end, if it has to go back, so that means there happens a reverse logistics. So it will go back via transportation. It will go back to the manufacturing or to the service industry. Now there is another term which has of late come, and it is an economic term. They call it as circular economy. So what is actually happening in circular economy? It is an economic system which is focused, or it aims at eliminating waste and continually uses resources, which will be products and material. They will be recycled, reused, or regenerated. As I defined that there is a term reverse logistics, so that means the material which has come to the client or to the customer is sent back to the industry, that is original manufacturer, or to the service from where it had initiated. So looking at that, what we tried to find is that Industry 4.0, it has a lot of different technologies classified under it. They have been established irrespective of their original, where they came from. They can be related to social, political, economic, and environmental initiatives. They can be solutions, they can be applications, apps, or some part of it can be a larger technology that is being used. What we have found, what we explored through our, and we got a very nice review that one of the comments in the review that yes, it has been done. It has been identified very clearly that in reverse logistics, in that sector, that is outbound reverse logistics, that means from client to your manufacturer or service where it starts, there have not been many studies. So this paper tries to, these 10, we have given 11 pages. We have given the full paper, and we would like to see whether it goes as a publication or it gets into one of the, it is requested for a journal. So we have tried to fill in these gaps. Now this third part of the title, which termed at Bayesian best-worst method and COBRA. So we have integrated these two things all together. So what I would like to say here is we tried to find out through the last 15 years. We went into the articles which were related to reverse logistics. We got nice, good papers. We got good papers of Mahdi Raj. We got Kumar et al. We got from C et al. There were very good papers that have come up, and they have dealt in little bit of reverse logistics and in Industry 4. So we were able to select our criteria. So 6 criterion have been evaluated. They have been classified under technological, socio-political, and the economic the operation. So what we did is first was the evaluation of the criterion where Industry 4.0 in reverse logistics as general as whole has been applied. The second thing was to identify in the Industry 4.0, in the industry, what are the alternative technologies that are available. It is a large gamut of activities that is happening under Industry 4. And we were able to, just a while ago, in the earlier presentation, they were talking about artificial intelligence and how it can be. So I would only like to say there that it means enhancing decision-making through artificial intelligence. So we were able to find out through these very and more papers that what are the alternatives that are under Industry 4. For example, blockchain, cloud computing, big data, 3D, automated printing, advanced robotics, Internet of Things. Then we have artificial and Internet of Things. So these were about 10 of the alternative technologies that were in use. So now what we have to find out using the 16 criterion and looking at the 10 different technological alternatives, we would like to identify which is the best technology that can be utilized, that could be helpful in decision making. So what we did is we combined the Bayesian best worst method. These are done in 6 steps. Here we define, we select BW criterion. We look at the parameter pairwise comparisons. We look at the best and the worst particular comparison factor. We develop them. Then we look at the aggregate weights. We refine the weights using the Markovian model. And when this is ready, we try to work on the COBRA method for ranking and evaluation. So here also we have the steps. This has been given, beautifully described in the paper, in the annexure, all the equations, because we got our results from here only. So they have been provided. And any questions on this, we would like to receive them, and we would like to respond them by an email to the person who raises it. So this is the methodology that we tried. So in the first part, when we have the 16 different criterion, so that means we are looking at the first part here, and we tried to get the weights, we aggregate weights, and finally using the Markovian. So I have to go down, yes. And then we get, for these 16 different criterion, we get the best and worst, and then we get our ratings, the weights, and the weights are available to us. The second part was to look at the alternative ratings, taking these 16 criterion and the 10 different alternatives. So Sati scale was used, and we tried to find out from there, and we arrived at a table. This is given the description More details are provided in the paper, and we can work them out from there also. So after that, we tried to look at the validation using both the methods. We compared with various others, AHP, Topsys, VCOR, Mura, Vaspas, Marcos, Bwm Cobra, and the Bayesian Bwm Cobra. So these methods separately and together. And we found that the technology at T4 has given us a different value evaluation, and it was being validated. So variations may arise from the Bayesian approach. Say they capture the objective preferences and they integrate them with the CORBA ranking process, which differs fundamentally in how criterion weights and the distances are handled. So what we infer from here is that it mentioned, we could find out that out of the industry 4.0 technologies used for RL, reverse logistics, the best is the IoT, followed by cloud computing, and then the mobile marketplaces. And we have genuinely seen as an example that has been taken, and it really does work on it. So it is the best ranked technology as it initiates, it accelerates the development of other IoT technologies that would be used with it. So it has given a comparison between where cloud computing would be used and where the other cloud computing, mobile marketplaces, they could be used. So in all together, coming back to the reverse logistics and relating it with the concept of circular economy in reverse logistics, we are able to find out that the impact is huge, and what is really required is cost reduction, is a value addition to that particular product, and finally to the product's life. So that was, we were able to identify it. Briefly giving what happened in this paper was we ranked industry 4.0 technologies for reverse logistics activities. We were able to identify from a literature review 16 different criterion. Then we looked at the multi-criterion decision-making approach. We used an integrated approach. We used the Bayesian best-worst method. We joined it with the COBRA method. It allowed us to identify IoT as the most applicable technology with some following things, and that is given, right? So we got this results. We tried to work out with what are the results in various other methods. And in the future, what we would be able to do is to look at various reverse logistics activities, try to integrate them. So that means it is emerging and it is a good concept and we can always use it. So if we look at our, what is called as the highlights of the paper, so the 4 highlights also relate to the same thing. Thank you very much. Questions, please? It's open.
Okay. You did the presentation in 15 minutes, but I believe we have time for a couple of questions. One, Pearson, Razan. Pearson, I think you are muted?
No, I am not.
No. We have,
Yeah. Can you hear me?
yes,
Yeah.
we can
Yeah,
hear.
so I'm not muted. But
Do you have any question?
I think it was very good presentation. It was very well explained.
I have one observation.
Yes, sir.
Professor Koul, if you can share again your presentation and go to slide 9, I think there is a controversial result that I like very much the work. The work is up to date, including things like circular economy and reverse logistics. But when you apply the Bwm with Cobra, you have one result that is totally different for other 7 methods, including AHP. And with AHP and other methods, I can remember Topsis and Marcos, and I'm not familiar with that, those methods, but slide 9, yes. All of them result in technology T1 ranked first, but
Yeah.
Bwm Cobra is T4. So this result is a little controversial to say,
Yeah,
at least. All methods goes to one direction, and what can you say about it? Did you have presented this work before, because I believe this is a controversial result. I'm not saying that it can invalidate the result, but it is, for me, it's a remarked question.
Okay. So what exactly we tried to look at is we tried to work on Bayesian Bwm first part, right? And then we looked, second part was only on COBRA. The COBRA method is used because we have to look at, it gives you a comprehensive ranking. It gives you a comprehensive ranking. So that means it tries to look at the distances from the ideal solution, right? So, and it can be compared with other methods. In this case, the differences that we were able to look at, because we received one in the rest of them, and we received only one at T4, it highlights to us that there is a potential to offer better insights. It also underscores the needs for deep understanding of the specific criterion that will be driving the differences in the ranking. So it will give you more insights why it has come at. So that would mean the criterions would have to be changed, the right criterion, because my query nowadays with Professor Verma and my friend Ajay is always why we select these criteria. And whenever I look at any of the MCDM paper, so many are coming. So the first thing is why only these criteria? Why not the other? What is a priority? Why it was taken? So it helps us to identify different perspectives. So from that angle, we found that it could be a better alternative for reverse logistics area.
May I come to, may I answer this question?
Yes, please.
Yeah, actually, this is myself, Rakesh Verma. Actually, because we are considering uncertainty in these questions. So Bayesian basically consider uncertainty. All other methods are basically crisp in nature. So we are basically considering uncertainty, and that is the reason why the answer is a little far behind than what other methods are giving. So the reason is that actually.
Dr. Verma, okay, and
hi.
it was in the conclusions. Birsen, I'm sorry, but Laura is telling me that
Very important. I missed it.
the-
I missed it. Yes, I
Okay.
missed it.
We move the next presentation.